for the simple parabolas, and we're still on y equals. And notice in my x value that's squared, and it's over here on the right. So I get the y by itself. So that's the first thing, is whatever variable is to the first power, make sure it's over here by itself. Now, if you'll remember, if the x is squared, we did a few of them, it's a parabola that opens up. So that looks really cool. So let's look at this and see if we can figure out what happens. Now, we already talked about this in a little bit, but if there's an afterthought and it's not messing with your x, this makes it go up or down. So I'm already going to tell you that this one's going to go down 4. Now, you don't necessarily have to memorize that. You can just plug in points, but that's nice to know. This one, this -2, is messing with my x, so it's going to mess with my mind. You would think it's going to go left 2, but it's going to do the opposite of what you think. So this right here is going to go make it go right 2. So before I even graph this one, down there on the lower part, let me just say a standard parabola looks like this. Okay, right here at 0, 0. But this one's going to go right 2 and down 4. It doesn't matter which one you do first. But if I go right 2 and down 4, I'm going to be right there. So it should be a parabola that looks like this. So if I was taking like the ACT or something and it was supposed to be fast, I could quickly pick out that parabola. I do want you to plot 3 points. So let's see if we can do this just with 3 points. Now, if I'm right, the point 2, -4 should be on my graph. Okay, and watch this. My favorite point to plug in besides 0 is 2. And let me tell you why, because when I do plug it in, do you see I do get 0? So 2 minus 2 is 0, squared, 0, 0 minus 4 is -4. And guess what? That's my vertex right there, 2, -4. And that will also be my axis of symmetry, by the way, right there. So my axis of symmetry is x equals 2. Now, here's what's cool. When you start to plug in your other points, I usually just plug in 1 point on either side. So since this is 2, I'm going to plug in 3, and I'll probably plug in 4. So watch what happens. When I plug in 3, 3 minus 2 is 1, 1 squared is 1, 1 minus 4 is -3. So when I get ready to graph this down here, and I'm going to go ahead and show you something, I've got 2, -4, so I'm going to come down here, and I'll start this first one with pencil. I've got 2, -4, and I had the point 3, -3. Now, I'm just saying, do you see this is my axis of symmetry? See how this is over 1? This will also be over 1. So I can just mirror it. And technically, there's my 3 points, but it is nice to go ahead and get another point over here so you can see how fat he is. So let's go ahead. I'm going to go back up here, and let's try 4. If I plug in 4, 4 minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. So, woo! Love that point. 4, 0. That's an x-intercept. Notice on my axis of symmetry, it kind of helps sometimes. See how he's 2 over? It's going to be 2 over. It mirrors it. It's symmetric. So I'm going to go ahead and do a nice, it's not a V. Absolute value is your sharp V. This is a smooth curve. Extend it. Okay. Put some arrows on it. Sorry, my paper's slipping, and I'm trying to do this one-handed while looking through the phone. So it's going to look something like this, and I'm going to label this one right here. In fact, I'm going to extend him up just a little bit further, and I'm going to label this number 4. Okay, so that's what that one looks like, and I've got all my points, so I'm done. Now, what is different about this one? This looks so much like the standard equation, but I have a negative outside. So you can probably have a good guess of what's going to happen here. But if I've got my x and my y, if I plug in 0, well, there's no such thing as a -0, so it's still 0. If I plug in a 1, what happens here? Just the 1 is squared, and then it's going to be on negative on the outside. So it's going to be 1 squared, which is 1, but it's still negative. So basically, everything over here will be negative because it's on the outside. So if I plug in -1, that still gives me 1, but I have a negative on the outside, so it's going to be -1. So we might try one more. Let's try 2. 2 squared is 4, but it's going to be a -4. Okay, so go down here, and I will do this one in a different color. I've got 0, 0. I've got 1, -1. And over here, oh, look. My vertex is still going to be 0, 0. And I have got 2, 4. Ooh, right there. So do you see this is my axis of symmetry right? I'm going to go over 2. Here I'm going to go over 2. So it's a nice smooth curve going down. Okay, this right here is number 5. So my vertex is still 0, 0. And my axis of symmetry is x equals 0. So this negative up front made him go upside down. So my parabola opens down. All right, so last one on this particular video. Look at what I've got here. Let's see what's going to happen. First of all, I have a negative out front. So it should open upside down. So it should open down. So I'm going to write myself this little note. It should open down. This minus 2 is an afterthought. He is not being messed up with my x. It's not squared. So this should make it go down 2. Now, for the first time, we haven't ever had a coefficient or a number sitting out front. It's just right there. So that is going to affect my graph, and we really haven't looked to see how that will affect my graph. So let's do my little t-chart over here. I'm going to have to try to write a little smaller. Let's plug in one of my favorites. If I plug in 0, that's 0. 0 times negative 3, it's 0. 0 minus 2, it's minus 2. Now remember, you can plug in anything you want, but you have to graph it. So I try to keep things a little small. If I plug in 1, I'm going to, remember, you do exponents first. So I'm going to get 1 times negative 3, which is negative 3 minus 2, which is negative 5. Okay, so let's plug in negative 1. That still gives me 1. Okay, but 1 times negative 3 is negative 3. Negative 3 minus 2 is negative 5. Okay, so maybe we should plug in one more just to see. Let's plug in 2. 2 squared is 4. 4 times negative 3 is negative 12 minus 2 is negative 14. So obviously when I plug in negative 2, I'm also going to get negative 14, which is going to be off my graph just a little bit, but hey, that's okay. Let me grab my red pen. So let's do 0, negative 2. And by the way, that's what's going to be my vertex. But if you don't see that yet, you're going to figure this stuff out. You will eventually. So there's 0, negative 2. I also have the point 1, negative 5. 1, negative 5. I'm going to mirror that over there because we also had negative 1, negative 5. Then I had 2, negative 14. And I'm just going to kind of guess, but he's kind of somewhere way down in here, and I'm going to mirror that over because it's symmetric. So what I have is this pretty skinny upside down parabola. Skinny, skinny, skinny. Okay. So that's what that one looks like. My vertex is what? 0, negative 2. So let me fill this in. This is 0, negative 2. My axis of symmetry is my x value still. X equals 0. Okay. Now, little hint when you find your vertex. The x value is what makes this 0. And the y value is the afterthought. Okay. So look right here. There was no afterthought, so it was 0. Here there was an afterthought, so what made this 0 was 2. The afterthought was minus 4, so that's my vertex right there. Here, it makes it 0. Afterthought is 3. There's my vertex. Here, what makes this 0 is negative 3. There was nothing afterwards, so there's my vertex right there. Negative 3, nothing over here, 0. So that kind of helps, maybe a little bit of a little trick. What did this 3 do out front? Well, if this was positive, it would make it go up 3 times as fast. So it affects it vertically. It's like some big giant was up there stretching the ends, and it's going to be tall and skinny. So since it opened down, he went down 3 times as fast. So that's basically what happened there.